In this video lesson, we are going to introduce polyatomic ions and how to write chemical formulas using them. You maybe have looked at a nutrition label, an ingredient list, and maybe you've seen things like sulfates or nitrates. And so you'll find that there's a lot of chemicals that end with the suffix ate. Sodium phosphate, calcium carbonate. So we are going to explore these things. They are called polyatomic ions, which are groups of atoms that carry a charge. They are found in our food ingredients, they are found in our natural waterways, and many other chemical compounds you encounter every day. So this is taken from a POGIL. This is model number 1, types of ions, and we have something called monatomic ions, and we have something called polyatomic ions. They're both ions, which means they are charged particles. And monatomic versus polyatomic, you might guess, has to do with the number of atoms that are in those ions. We have an example here of something called nitride. It is the symbol N for nitrogen, and it has an overall -3 charge. We have sulfide, which is the symbol S with a -2 charge. And we have Cl, which is chloride, with a -1 charge. These are all monatomic ions. They are ions made up of one atom. Polyatomic ions, we have something that's called nitrate, different from nitride. We have nitrate and we have nitrite. We have sulfate and we have sulfite. We have ammonium and we have hydroxide. So if we go back and take a look at the ones with nitrogen, right? Each one of these has nitrogen. This one has 1 nitrogen and 3 oxygens. And collectively, this whole thing, all these atoms together, have an overall charge of -1. Nitrites are similar to nitrates. If we look here, nitrate has 3 oxygens, but nitrite has only 2 oxygens. The overall charge is -1. Sulfide, sulfate, sulfite, they all have a -2 charge, but the sulfates have oxygens, 4 oxygens combined with them, and the whole particle overall is a -2 charge. The sulfite has fewer oxygens than the sulfate, overall -2 charge. We have ammonium, different from ammonia. This is ammonium. It is a nitrogen and 4 hydrogens overall with a +1 charge. And this is hydroxide, which is an oxygen and a hydrogen collectively together has a -1 charge. So using this model, let's complete the table below. The charge on the nitride ion, is indeed a -3. The type and the number of atoms, there is 1 nitrogen in the nitride ion, and the chemical formula is just N-3 or N3-. Either way is good. Nitrate with the ATE, nitrate is this one right here. Overall charge is -1. This one has 1 nitrogen and 3 oxygens. The overall chemical formula is NO3. I'm going to put that in parentheses because overall that group of atoms has an overall -1 charge. Sulfate, overall charge is a -2. It has 1 sulfur and 1 sulfur and 4 oxygens. 1 sulfur, 4 oxygens. The chemical formula would be written as SO4 in parentheses -2. Sulfite, this one, sulfite, different than sulfate, different than sulfide. Sulfite overall charge is a -2. There is 1 sulfur and 3 oxygens. and has the formula SO3. We're going to add a parentheses. We're going to keep the -2 on the outside of the parentheses. Ammonium overall charge is a +1. There is 1 nitrogen and 4 hydrogens. And the chemical formula would be NH4 in parentheses, overall charge is a +1. On the next page, the question, consider the terms monatomic and polyatomic as they are used in Model 1. Write a definition for each of these terms. It may be helpful to break the words apart. Okay, so monatomic is, and we're going to add ion here. A monatomic ion is an ion consisting of only one atom. A polyatomic ion is an ion consisting of 2 or more atoms. We're going to now consider reference table E from your chemistry reference tables, and I've printed it here for you to take a look at. What we're going to do to start with is we're going to add parentheses around each group of atoms to highlight the fact that it is the group of atoms that has a charge. So we're taking a look at the first 3, which are very interesting because these are the only cations in this entire reference table. But if you have H3O with an overall +1 charge, it's called hydronium. Hg subscript 2 with a 2+ is an ion called the mercury 1 ion. We're not going to use this one very much. Ammonium, we'll use this one a lot. We're going to put parentheses around the NH4 and squeeze that in there. The overall charge on an ammonium is a +1. Now all the remaining ions here are anions. They're all negative. We see acetate here. Acetate is written in 2 different forms. You just need to learn to recognize that they both exist. They both represent something called acetate. They both have 2 carbons. They're just split up here and here. They both have 3 hydrogens, and they both have 2 oxygens. The overall charge is a -1. Cyanide, like the poison, is Cn with an overall charge of -1. Carbonate is CO3 with an overall charge of -2. Hydrogen carbonate is HCO3, overall charge -1. This is the same thing as bicarbonate. Oxalate, C2O4, overall charge -2. Now we have a series of ions that are all related: ClO, ClO2, ClO3, ClO4. And so their names are all kind of related here. ClO with a -1 charge is called hypochlorite. Hypo is not hyper. Hyper means above, hypo means below. So hypochlorite has the fewest number of oxygens in this whole series. When we're able to get another oxygen in there to have ClO2 with an overall -1 charge, this is called the chlorite ion, ITE. ClO3 with a -1 charge is chlorate, ATE. And then ClO4, this is the one with the most amount of oxygen. ClO4 with a -1 is called perchlorate. This is shortened down from hyper, like as in hyper as in an excess. Now, keeping in mind, you don't have to memorize these. This is a reference table on your reference table booklet. But the more familiar you are with them, the easier the road, your path is going to be for the rest of the year. So we're going to take some time and just kind of look at each one of these one by one to familiarize ourselves with what's here. So continuing on the other side, we have 2 ions containing chromium. We have CrO4, overall -2 charge. It's called chromate. This one, Cr2O7 with 2 chromiums, is dichromate, same charge though. MnO4 with a -1 charge is called permanganate. NO2 overall with a -1 is nitrite. We saw that on Model 1 just a moment ago. NO3 overall with a -1 charge is nitrate. Different from when we had N, just the monatomic ion that we saw a few minutes ago. This was nitride. So not a polyatomic ion, but the names are also similar, but they have a different ending, and that ending is important. Peroxide is O2 with a -2 overall charge. Hydroxide is OH with an overall -1 charge. Phosphate, PO4 with an overall -3 charge. Thiocyanate, SCN with a -1 charge. Sulfite, sulfate. Sulfite is the SO3. Sulfate is SO4. Both have a -2 charge. Hydrogen sulfate, HSO4, overall charge -1. And then there's thiosulfate, S2O3 with a -2 charge. Okay, again, you're not responsible for having these memorized, but the more familiar you are with them, things get a little bit easier. Okay, so what we are going to do now is we are going to be using that reference table E, and we are going to use them to help write chemical formulas. Sometimes you are straight up given the ion symbols from which you have to do the crisscross or the drop-in swap. So we are still using the same strategies we used before, where the overall compound has to be neutral. And in a few minutes, we'll take a look at it. Well, what happens if you're given the name? How do you write the formula if you're given the name? So let's start with the ion symbols. If you have a lithium ion and you have the hydroxide ion, we are looking at their charges +1 and -1. We only need one of each. If we drop and swap, we're going to get Li. So this one comes down over here. This one comes down over here. You could write it as Li1, OH1, but those ones are going to cancel, right? There's one of each. And so we just drop those ones. And because we only need one hydroxide, we do not need to keep those parentheses anymore. The parentheses really come in handy only when you're trying to show the charge or when we need more than one of them in a compound. So let's see that in the next example. The next example is this NH4 +1 and this sulfide ion -2. So this 2 is going to come down here, and this 1 is going to come down here. And now what this means is we are going to need 2 of these NH4s. So here's where we have to keep the parentheses because we need 2 of them, but we only need 1 sulfur, so we just write the S, right? Because really what we are saying is we have 1 of these, 1 of these, and 1 of these. And overall, all this charge adds up to 0. So this is our final formula. We're keeping the parentheses because we needed more than 1 of those NH4 ions. The next example, we've got a +3 on the ion and on the iron and a -1 on the anion. So dropping and swapping, we would get Fe1, ClO2. I'm going to keep those parentheses because I'm going to need 3 of these ClO2s. So I'm going to rewrite it because I do not need to include the 1. So this is Fe, open parentheses, ClO2, close parentheses, 3. Ca +2, PO4 -3. Dropping and swapping. I'm going to have Ca subscript 3, PO4 in parentheses subscript 2. Now in this case I have to keep the parentheses because I need 2 of those PO4s, not just 1 of them. In this next example here, I've got Pb +4 and CO3 -2. Dropping and swapping. If I rewrite this, I'm going to have Pb subscript 2. I'm going to have CO3 in parentheses subscript 4, but that 2 to 4 is a reducible ratio. So this becomes Pb CO3 in parentheses 2. All right, now what we have to do when we're given the name is we have to first figure out what the ion symbols are. And so this is a little bit of an extra step, but once we have those ions, we're just going to do the drop and swap like we did on the other side. Okay, so sodium is a metal. We know sodium is Na, and we know it has a charge of +1. Acetate is on our reference table E. Acetate can be written either of these two ways. I'm going to choose the top way, the C2H3O2 with an overall -1 charge. C2H3O2 in parentheses -1. Now because it's a +1 and a -1, I just need one of each. So I'm just going to write Na, C2H3O2, and I do not need the parentheses because I only needed one of them, and the parentheses are helpful when you need to show that you needed more than one of them. The next one, calcium hydroxide. Calcium, Ca +2. Hydroxide, going to reference table E, hydroxide is OH with a -1. Okay, because these charges don't balance each other right away, I do need to do the crisscross, the drop and swap. And I would get Ca with a subscript of 1, and I would get OH with a subscript of 2, keeping the parentheses because I need 2 of them. The only other thing I would change is we don't need this 1, so this just becomes CaOH in parentheses 2. Ammonium sulfate. We're not going to find ammonium here on this periodic table, but we are going to find ammonium on reference table E. Ammonium is NH4 with a +1. Sulfate is SO4 with a -2. Okay, so now we have 2 polyatomic ions in this formula, making it a little more complex, but we can do this. Keeping in mind that we're not changing anything about the subscripts that are inside the parentheses. Those stay as is. We are only bringing subscripts outside of those groups of atoms. So this 2 comes here outside of the NH4. This 1 comes here outside of the SO4. I do need to keep the parentheses around the NH4 because I needed 2 of them. I only need 1 of these SO4s, so I do not need to keep those parentheses, nor do I need to write the 1. So that's the formula for ammonium sulfate. Barium nitrate. Barium, Ba +2. Nitrate. Be careful here, you're looking at the right one. Nitrate, this is NO3 -1. NO3 -1. Dropping and swapping, I'm bringing that 2 down, I'm bringing that 1 down. This 1 is going to disappear because I don't need to write 1s as subscripts. Because I need 2 of these nitrates, I do need to keep those parentheses. And the last one, tin 4-thiosulfate. Tin. Tin is SN. It either comes in a +2 or a +4, and we know which one we're using because Roman numeral 4 tells us that this is the +4. Thiosulfate is S2O3 with a -2 charge. S2O3 with a -2 charge. When I crisscross, I'm going to get the 4 down there, I'm going to get the 2 down here. I would rewrite this as SN subscript 2. S2O3 in parentheses followed by a 4. But you maybe can see that this 2 to 4 ratio is reducible, so this should reduce down to SN, S2O3, keeping those parentheses because I still need more than one of them. In fact, I need 2 of them. So there you have it. We have learned about polyatomic ions. We have learned how to use polyatomic ions in writing chemical formulas. And so this hopefully adds to your collection of tools on how to write chemical formulas for ionic compounds. All right, that's it. We'll see you back in the classroom.